those of us in the Northern Hemisphere, I don't know about you, but we're getting more light. Ha ha! The future is good. So anyway, we're all working to try and save the planet, right? Like, let's all take a couple breaths and notice how beautiful it is. Look at the sunset. Check out that spattering of snow and how gorgeous it is when it first just comes down. Just let's all appreciate and slow down. So toast tonight to appreciating nature. Cheers. I'd like to introduce Sian Taylor, our speaker for tonight. She was one of the first certified passive house designers in New Zealand and has played a really pivotal role in passive house adoption in New Zealand. She first trained as an architect in the United Kingdom at the University of Wales in Cardiff, and she currently lives in Otago, where she started her practice, which is called Team Green Architects. Her architectural practice has helped show us a pathway for fusing high performance building with design excellence and has really helped raise awareness and profile of passive house design and construction in New Zealand. So super excited to hear from you, Sian. Thank you for joining us.
Thank you. Okay, I'll just go to share my screen, bear with me. Okay, so as Bev said, I am Sian Taylor. I'm from Arrowtown in New Zealand, which is the South Island of New Zealand. And I became Passive House certified in 2012. I'm an architect by trade and continue to be. And a year after I got certified, we started Team Green Architects. That's my partner and I. And we design residential buildings in our region, and they are all using the passive house process. So we use PHPP. Everything is highly insulated, almost always using triple glazed European joinery because our climate is very extreme here in Arrowtown. We have very cold winters with snow, sort of -9, and we have very hot, dry summers. Thermal bridge as free as much as possible, and air tightness, obviously, and balanced heat exchange ventilation in everything that we do. That said, not everything reaches certified passive house, but this house, which I'm going to talk about, which is our house, was certified passive house. So the story is this: our building code here in New Zealand is pretty woeful, and this is where we were living, and this is what we wanted. So we're in a typical New Zealand house, which this house was built in the 1980s, very thin, sort of 90mm walls, aluminium single glazed windows. And although this view is absolutely stunning in the summer, we've got Lake Wakatipu here and this mountain ranges all around. In the winter, for 2 or 3 months, this is what we were looking at, which is condensation, or that's if we were lucky, if we kept the curtains open, because it was so cold, often the curtains would close. And whilst we were living here, we were building homes which were warm, comfortable, healthy, low energy, and it reached the point that we had to do something ourselves, which is what led to this. So the first thing was, where do we build? And what we were looking for was land which was north facing. So this is the site that we bought. But we fell in love with this piece of land for a number of reasons. Obviously, the view is incredible. It's quite sheltered. As I said, it's north facing. But this farm here used to be Mark's granddad's old farm. So he has lots of fond memories of this area. So it was also somewhere which was really undervalued at the time. I couldn't understand why. We were building lots of houses in this region and looking over at this land thinking, why is no one living there? Now almost all the sections are developed and it's completely different in terms of the value. But at the time, we just fell in love with it and thought as well that this big piece of land here was big enough for us to build quite a simple flat site house. But as with everything, when you're overtaken with the emotion of how great it is, we we actually didn't realize just how much the site drops off here in terms of the area you can build on and goes back up the hill over here. So in fact, the incline of this site was incredibly steep to get a flat, a building that could have suited a flat site. But as with everything, the challenge meant that we've got a solution that actually benefits us in a lot of ways. So this is the final design, as in what we aim to achieve if we ever win the lottery. So what we've built right now is this bit here, and this essentially is a 2-bedroom. There's 2 bedrooms. We live down here. There's 2 bedrooms at the back and a bathroom, and then a living, kitchen room, dining room, and that is around 80 square meters. As I said, this is north facing, and I believe most of you are probably in the States, so you're probably wondering why the hell it's north facing. That's because that's where our sun is. And the roof slope also benefited us because then we can get solar panels on that roof. And the slope of the land meant that we could build this second story, which allowed us to build what originally was going to be a guest accommodation for my parents. I'm originally from the UK. So it's kind of like a bedroom, bathroom, living space. But we basically moved in literally a couple of weeks before the first COVID lockdown. So this had to become immediately our office space. And within a very short space of time, I said to Mark, I didn't want to go back to our office in town. Not only is it wonderful living out here, but this house is just so comfortable, warm and pleasant that I knew this is where we wanted to be. So as a result of all that, we've completely gone to remote working. Mark and I work in what was supposed to be the bedroom. We have a sort of client meeting space in what was the living room, and this is our commute to work up here every day, which I realize we're very lucky to have. So the next challenge was the thermal envelope and achieving certified passive house. And I know from the work that we do that the 2 ways to make it cost effective is, number 1, get your orientation right, maximize what's free, which is obviously the sun, which we already had in terms of our site, and then keep it really simple. So essentially the plan of this is a rectangle or almost a square, and it's just got 1 roof. So it's a really, really simple thermal envelope, which is critical to keeping the cost down. But it did come with its challenges. We've got this area at the back that we needed to retain. So we had to have a different type of construction for retaining at the back here. But essentially what we did, every single wall aside from this rear retaining wall is 165mm SIPS panel. But this retaining wall came with its own challenges because we have blockwork retaining concrete block here. We have 100mm of XPS on the outside, and we needed to line up the SIPS panel with this XPS. And obviously the structure needs to line up as well as the insulation, which it's not doing. So that was one of our first sort of thermal bridge detailing challenges. This detail here shows what we ended up doing. So this is the blockwork wall. This is the interstory detail. This is the 100mm of XPS. This is the SIPS panel. And all we've done is basically bolt a piece of 2x4 to the wall here, and that supports the interstory ply and then the SIPS panel on top. But what it meant is that the rafters, which are here, couldn't actually be supported on the structurally insulated panel, which they typically would have been, because the load line was not direct. So we had to put an additional 90mm frame, which is the only place we've had to do this, along the back wall to support these rafters. So everywhere else we've got the SIPS, and then we've got 45mm internal cavity fully filled with New Zealand wool insulation. The roof is a warm roof. Even though it's sloping, we've got a warm roof construction. So the air tightness actually is here, but we put an extra insulating batt underneath. And we ended up, it's not shown on this detail, but we actually ended up putting in tallow here as well, even though we've got our airtightness up here. We just wanted to achieve the highest level of airtightness that we could. And then our slab detail, again, was just trying to keep things simple. Typically in New Zealand, we insulate below the slab, and a lot of people have exposed concrete slabs. But to maintain a really simple thermal bridge free situation, we've got the SIPs, and then we've got the insulation above the slab, as is shown here. So this just shows this is on site. So that wall down here is where this is the piece of timber that was bolted to that wall. This is the SIPs panel. That is the piece of ply that's the interstory ply. And that is the tanked insulated blockwork wall below. So next challenge was windows. Windows are obviously expensive when you're doing a passive house. And if you look back, I'll just take you back to here. The original design just kept it really simple, glass all the way across. But when it came to it, that was going to cost too much money. So this big window here, which is the biggest slider that you can get, especially when you're transporting overseas, this whole window costs about $17,000. And every other window in our house, other than these two here, is very simple. We've got, I'll just try and show you, we've got square windows which just repeat themselves, these little squares. And they were about $900 each. And then we've got this massive, expensive window here. So to keep costs down, we basically changed the design and went for the biggest bit of fixed glass that we could get here. We've got an opening panel here. And it meant that we could have a change in the feel of the room, because this is the kitchen, the dining room here, and then we move into the living space here. So this is a lot more cozy. We've got a sofa behind here, and it just changes the feel within what is actually quite a small space. And then the cat flap. So this was an absolute nightmare, and it's embarrassing to say, but basically we didn't allow for a cat flap at first. Before we moved in, we weren't sure if we were going to get a cat or a dog, and then we got a cat. We moved in, and then, as I said before, it was lockdown, and we found two little kittens in our garden, which was our lockdown project. So we now have 3 cats, which was not the intention. So we had to put in a cat flap, and being architects, we're a little bit anal about things like lining up with cedar panels. Every single window lines up with the cedar, and each wall finishes on a complete cedar panel. So this had to line up. The cat flap in itself is expensive. It was a US one. I think it was, I don't know, $700 or $800. But it took a builder 2 days to cut this into the wall, form the flashings so that they perfectly suited this cedar cladding. And the cats can't use it because it's too heavy and too airtight. So after all of that, we've got this ridiculously ugly piece of timber with a bit of plastic holding the cat flap open and creating a hole in our airtight building to let the cats in and out, which seems absolutely ridiculous. So that's it. As I said, it's certified passive house, and we've been lucky enough to win a few awards, including most recently the winner of the Housing Award for New Zealand Institute of Architects, which is a great pleasure. And that is our passive house.
That is fantastic, Sean. We're going to go over to Zach, who's going to kick off some sponsors, I believe, and then we'll dive into questions. I'll load up the question queue.
I am. I was madly doing some chats, and so I have to bring up my thank yous. But I am about to thank the fine organizations that make everything that we do at the Passive House Accelerator possible. So here, I'll share my screen. And So a big thank you to our founding sponsors, 475 High Performance Building Supply, Bax Ingwe Architects, Glavel Foam Glass Gravel, Minitair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Thank you also to our champion sponsors, Icon Windows and Doors, Proseco, and SIGA. And thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks too to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan Insulation and Airtightness, Brooklyn Solar Works, Euroline Windows, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you.
Wow, Zach, that list of sponsors is getting long. That's great stuff. Thank you to our sponsors. All right, Sean, hopefully you had a moment to catch your breath, had a sip of whatever you're drinking on your Thursday, but us that are in North America are enjoying our Wednesday afternoon. And the question queue gets started. The question period gets started with Enrique. Enrique, where are you?
Yep, here.
Ed.
I just was wondering if you're getting enough solar gain because of that large covered porch that you have in front of the windows there, the main windows.
Yeah, sure. That porch is essential to avoid overheating. So what I could have done, which is quite helpful, but you can actually see, should I go back to share screen? In the winter, we get full sun right the way through that living space. And in the shoulder seasons, it starts to come back. And then in the height of summer, the overhang is specifically designed to stop the sun coming in past that, the windows. So we have no overheating, which is a big problem in our region and has been the only issue we've actually had with the houses that we design has been overheating. So it's something we're really keen to address. And we get full sun when we need it.
Okay, thank you. Ideal shading strategy then.
Yeah, if you're exactly due north, or in your case, I guess due south, it's actually really easy if you do the correct design of or geometry of the overhang. It's very easy to get it right. As soon as you're slightly off north or south, and you've got east or west, it's much harder.
Yeah, thank you.
Thanks, Enrique. Jeff X got a couple of questions. Jeff, over to you.
Hey, how you doing? I'm really curious, being the estimating nerd that I am, how much time on the installation you got in that big slider? These things are hard to maneuver. I mean, how much time you got in putting that thing in?
It didn't take them that long, I don't think. You needed a lot of guys to carry it. But I mean, God, I actually can't remember, but it wasn't, a couple of hours, maybe, I don't know.
Oh, that's not bad at all.
The thing that was really scary is that we had the windows delivered with another job about a year or two before we built the house, and we had them delivered in a container to the house that we were living in, and they had to be unloaded and put in another container for storage. And I realized during the unloading process that we had no insurance for them because we're obviously not on site, and I was terrified of the guys dropping that massive slider that they didn't.
First passive house door I installed, they dropped it out of the back of the truck.
Oh man.
Yeah. What was the brand on the slider that you used? Because I mean, I've heard some horror stories about these things, about getting them adjusted right.
It's Dopfner, Doepfner. It's German. We have a company we use in Australia who import them.
Interesting. And one last question. You gonna post the name of that cat flap?
Oh yeah, I'll find out what it was. It was from the US. I can't remember.
Yeah, we looked last week when we did the run through, and I know if you just do Passive House cat flap, there's a couple that pop up in the Google. So
yeah.
Oh really? Okay, cool.
Yeah, one of the two will work. Now let's dive into the cat flap for a second, because this is an interesting story. So now you have this hole in your passive house, and I'm assuming that hole is bigger than all the rest of the pinholes in your entire project. So you've done a blower test with it and to see the difference?
No, it'd be a good idea though.
Cat flat controversy. Let's get into it.
Yeah, well, look, to be honest, because I mean, at the moment we're in the middle of summer or just coming to the end of summer. So we leave, because we're home now all the time. I'm in the upstairs office right now. We actually leave our slider open most days, so that cat flap doesn't get open like that. And if it gets cold, then we shut it, obviously. One of the cats has learned to use it, so he can get in. And then the others just have to wait for us.
I'm laughing because, again, of course, you know, the chat is just going fun with all this stuff, and I think Ken's cat gate is the best one out of the bunch. But anyhow, gotta love the chat for just bringing humor to make us laugh. So again, glad that the cats have an access in and out. And I mean, given your space with that slider is that must be part of the natural ventilation strategy you have right now.
What do you mean? Sorry.
Oh, sorry. Just with having that door open on the lower floor, and probably you've got a window on the upper floor, and so you're probably getting a bit of a ventilation or a breeze through the home. Will it?
No, look, to be honest, it doesn't. We don't have. You're talking about the stack effect. We don't.
Yeah.
The upstairs and the downstairs do have a connecting door, but it's actually locked. So there isn't a connection between the two from a natural ventilation perspective. But we just leave it open because I guess we're just lazy.
Oh, the part, you know, the benefits of owning a home and then having to walk your long commute upstairs.
Yeah.
You know, I hear you. All right, sorry, let's dive into the question. Sorry, everyone, didn't mean to carry on with the cat discussion. We have Al. Al, you're next.
Yeah, I was just gonna ask you, since you got that door, well, locked or unlocked upstairs there, do you have any thermal temperature gradients between the lower level and the upper level that's noticeable?
Yeah. I don't have any testing. I need to get it, you know, in terms of tracking what the temperature is. But what we've noticed, which is really, I was surprised at, I should say, because upstairs here, we've got a window on the east, a window on the west, and one window on the south. Downstairs, we've got that big north window, and then we've got windows on the east and the west. The only place we get hot, which is what I find strange, but is upstairs, where we have no north windows at all. And I think there's a combination of the fact that we've now got the office here, so we've got 3 computers and a server all the time. We've also got the biggest west facing window in the whole house is the door and window over to the west. And obviously we get a lot of, in New Zealand where we are here in the summer, it gets both dark and it's the first time it starts to get cold because the sun's still really hot till 9-10 o'clock at night. So west is our killer in terms of overheating. Yeah.
Okay, yeah, we've got a 2-story townhouse that's got you know, fairly good sloping roof line, just like yours, and yeah, we find that we get a little bit of temperature gradient during certain times of the year here too. So
yeah, we also, we're quite lucky as well that because all the bedrooms downstairs are at the back against the retaining structure. You do notice as you walk through, there's a sliding cavity slider between the living space and that space, especially on a warm day in the winter, especially because we've got the most sun coming into that living space, that there might be a couple of degrees drop. And I don't know anyone else who's living in a passive house might feel the same or not, but I think you become much more sensitive to really minor changes in temperature. Whereas when I lived in my freezing cold previous house, which had ice on the inside of our bedroom windows for a lot of the year, that when you're that cold, a couple of degrees when you're cold and getting colder doesn't make as much difference.
True. Cold is cold, and
Yeah.
doesn't matter.
Yeah.
So Sean, are you happy now that you put the sweater on your house instead of always having to wear one?
Yeah. I love it. And we have to still convince our daughter, who's now 7, in the winter, we have to remind her that it's going to be cold when she goes outside. And she doesn't like it. She has to put clothes on.
Well, let's just one thing we didn't dive into was, and I apologize, there's a couple more questions in the queue I'll get to in a second, but can you just talk about your mechanical systems, HRV, hot water, and I'll work on pulling up the rest of the questions.
Yeah, sure. So we've got the Zender balanced heat exchange system, and that just pumps air into the living spaces and bedrooms continuously and extracts continuously from the bathrooms and kitchen. The only time you notice it or hear it is when everyone's gone to sleep at night, and then you can hear a slight sort of sound. And you have boosts obviously in the bathroom, so if you have a shower, the boost goes on. And then hot water is a hot water heat pump. It's the Stiebel Eltron, which is a German system, and it's outside, and that does all our hot water heating. We calculated that we have 1.1 kilowatt requirement when it's -9 for our heat. To be honest, it's not when it's -9, it's when it's been cloudy, which we're quite lucky here in the mountains. We don't get a lot of cloud, but if it's been cloudy for a few days, and we've got, to counteract that, we've got 3 500-watt panel heaters, which just go on if it drops below 20 degrees. And we don't, as I said, we don't have any overheating. So aside from this space upstairs, when we just open we've got windows both sides, so we open those if we get warm up here. So we don't have any mechanical cooling.
Excellent. Thanks for the update with that. And when you're talking about that west window, have you thought about some type of shutter to help out with the that extreme, or is it doable?
We've got internal blinds, and actually, interestingly, this was actually quite interesting. That caused one of the panels, because they're the blinds which fit within the joinery, and you can move them up as well as move them down. So we moved it to halfway across the window, and we went away for a weekend, and came back, and where we put it over just part of the window, the whole thing cracked on the inner pane, and because it got too hot, and because that space between the internal frame of glass and the blind, which is really close, gets extremely hot. And I've noticed that when you stand next to your windows and it's sunny outside, if you've got the blinds down, it feels like you've got a heater on. It was then that we found out that the company that we went through don't just buy, unless you ask for it, don't put annealed glass on the inside piece of glass. I also didn't realize, but I was quite pleased to find out that we have 0 excess on glass for our insulation. So the whole piece of glass, I don't think they're expecting it to be European, and the installation was free. So yeah, it's been replaced with the proper glass. But it's made me really conscious of the fact that you've either got to close the whole thing or open the whole thing in terms of the blind, because if you just do it over part, it obviously is too much heat in one place.
Again, great insight, and again, great lessons learned in your home. We've got Sebastian, you've got a question.
Hi there, Sebastian from Melbourne here. Great looking house, by the way, so congratulations. I'm new to Passive House, and I've been looking at the Passive House New Zealand High Performance Construction Detail Handbook, and just wondering if that had influenced some of your decision making in the wall types that you used in your house, and if you did use that manual, was it useful?
No, that manual has come out after we've designed this house, I think it's great though. So no, it didn't influence it. I think we at that stage we'd probably been detailing this way for quite a few years. So we knew what we needed to do to keep it simple. You had a second question. I'm just trying to remember what it was.
I was just, is the booklet useful? I'm new to Passive House, so a lot of the booklets that, a lot of the Passive House details that we see are based on overseas experience from Australia and New Zealand. And so I guess I'm trying to look at, details that are more conducive to local builders than showing them details from the Northern Hemisphere. So you're using SIPs, and, is that something that the local builders found relatively easy to get a grip on?
Yeah, that's an interesting question, and I actually was going to comment on that. We don't actually use SIPs that much. A couple of reasons for that is it is almost always more expensive here because it's not just the product, but also the builder installation. One of the issues that we found is that you've got to continuously keep it covered in case of rain, because if it does rain, or if it just rains even just a little bit whilst the builders are on site, it's like a wheat fix, and it will expand, and then that makes the cladding or any part of the next layer of stuff that the builders have got to do take a really, really long time.
Right.
So it doesn't really have any of the benefits of time that I thought it would have. I think thermally it gets you around a lot of issues, not necessarily that you couldn't get around with other forms of construction. Timber framing is the main thing that we do here, and fully fill that with insulation. But it means things like corner details here in New Zealand often get left as a big gaping hole, or they're just filled with timber.
Same here.
And obviously, if you've got SIPs, it's something that's taken care of, and you don't have to worry about what the builder's done. But it can be problematic. In general, now we just use 140mm framing, make it airtight with Intello, and then put an internal 45mm frame
for the wiring, so that the Sparky doesn't put holes in everything.
Yeah.
Right. Thank you.
All right.
Thanks, Sebastian. Now we're over to Brian, who had connected with Zach. Brian, let me just hopefully know which Brian I'm talking about. Brian, your last name, Brian. If you know which Brian. Perfect. Sorry, I didn't get that. Sorry, Brian, go ahead.
I was just wondering, with the placement of the solar panels on the roof, having them closer towards the top rather than further down. I don't know that you deal with snow loads in your, that's a thing, but it's just kind of wondering what made you choose your location for the solar panels.
That was just the advice of the solar guy. I actually didn't go into the calculations, but he thought that was the best place to put them. So that's what we did. Yeah. And we've got 16, I think, which was, so we generate over the year, we're positive, but in the winter we are not, and in the summer we are over generating, but not significantly. Obviously we could have gone a lot more, but then we would have been over generating even more.
Great stuff, Brian. And again, Sean, sometimes we deal with tradespeople and they just put up the big thumb and be like, oh, we're going to put it there. And, again, one thing about Passive House is it's nice to have a plan, nice to have a model to figure out where things go. But sometimes it's just about, oh, we're going to put it so. Great stuff. Thanks, Brian, for that question. And Zach's got one. Over to Zach.
I do. So one of the things that's been really fun with co-hosting the podcast with Matthew Cutler Welsh, who is based in New Zealand, is learning more about the kind of the state of the building code in New Zealand and the big gap between code and passive house. So I think this is first, I guess, a request from Sean and Amy. If one of you could kind of describe what that's like for the audience here, because I think for folks who aren't in New Zealand, it might be even shocking to learn about that. And then any reflections about, I think in some ways then, as you're working with clients, potential clients or new clients, that could be an advantage, because you could say, hey, look, we can completely revolutionize the experience of a building with Passive House. But it also can be a challenge, right? Because it is so different from conventional practice. So I don't know if you could reflect on that a little bit. I just think it's such an interesting way that your passive house scene is different from the passive house scene in North America.
Yeah. Should I go first, Amy?
Sure, thanks, Sean, and then I'll jump in.
Yeah. Yeah, look, it is vast, the difference. And I think for us in the South Island, in particular the climate that we're in, it's probably made the convincing, I guess you could say, or the, what would you call it? But convincing clients that it makes sense quite easy, because you can quite easily demonstrate either with the use of the PHPP or now obviously our home or other houses we've done, but what the difference is. But to sort of break it down to some figures, a typical New Zealand house in our region, had it been designed to building code pre the last sort of change in building code, so similar to our old house, which I showed the picture of, you could have been anywhere from 250 to 300 kilowatt hours per meter squared per annum. A typical house now, building code minimum might be 100 to 150, and obviously I'm sure most of us know passive house is 15 or less. I think our house was about 13. So you've got this massive jump. But it also starts to influence, I think I said early on, that not all of our clients, or the majority of our clients, 80-90% will not go the whole hog to certified passive house, because we're so woefully behind. They already make this huge leap by using and doing everything else that is passive house. We're almost always way below 50 kilowatt hours. So you've already made this huge leap from where you would have been. So they don't always go the whole hog. I think if we were much closer in what the building code is, maybe making that difference would be something people would go for. I'm not sure, but that's my sort of experience of it.
Hi, everybody. Amy here from Passive House Institute New Zealand. So thanks, Sean, for that lovely tour through your house and how it all works and goes together. Yes, so I think in New Zealand it's changing a bit now, but the people really driving the passive house movement here have either spent a significant amount of time in Europe or are from Europe, because they just come to New Zealand and they're just shocked at the difference and how woeful the New Zealand building code is currently. There has been some recent changes to the building code where there's been an increase in the required R value for insulation, but there's still, there's no reference to the actual performance. So there isn't that feedback loop to say this is how the building should actually perform. It's just saying let's just add some stuff and hope that it makes things better. Yeah.
Great, thank you.
Thanks, Sean. Amy, don't go too far, Amy. We'll get some parting words from you in a few minutes. Just checking the queue. Sorry, Sebastian had a couple of questions. Sebastian, come back on.
Yeah. Just wondering, you talked about these really expensive windows from Germany and, then having broken glass. And I'm thinking, well, I know it's 12 weeks by boat to Australia from Europe and probably another couple of weeks to New Zealand. was there a decision why you went for a European window system as opposed to like here in Melbourne, we have a company called Pahama that does passive house windows. Was there a cost balance, or was there a supply issue, or just didn't know? Or because then I'm thinking if you do have broken glass and the windows from Europe and you have to get European glass, like try to get that out here during supply chain issues and during COVID and through the borders. And I'm just thinking, yeah, my head's just going to explode with that.
Yeah, look, at the time, as I said, we bought the windows a couple of years before we built, and the build, so this is now 5 years ago, probably, maybe even longer. We didn't have as many options here in New Zealand, and it was cheaper and at the time better than what we could get here in New Zealand. That has changed now, and we do use a really local supplier for most of what we do. That said, we've got a couple of jobs on site at the moment where the scale of the windows that we need, they can't do. So we have gone back again to using Enzyme, which is it's kind of like a curtain walling passive house system from Europe.
Can you put that in the chat, please?
Sorry?
Could you put that in the chat, just the products?
Yeah.
It'd be interesting to see.
Yeah,
Appreciate
I will.
And any local New Zealand manufacturers of passive house windows? Because obviously that's easier to get here in Australia than the ones coming from Europe. Yeah,
but there's a great Australian company who we still use, so I'll put them in as well.
Please.
But yeah, in terms of the glass though, the glass that broke, we actually got glass from New Zealand, because now in that time they have changed what they're doing, and it's not quite as good, and the edge spacer isn't as good as it would have been, but it is enough for what we needed on that window.
Thank you.
So just as we're wrapping up, Sian, maybe you can just give a bit of a timeline, because you've had a couple of years now of living in it, then you were dealing with construction. Maybe just give a timeline of when you first conceived it, and some of those timeframes of construction, because I had a few people just wondering about, how long this whole process looked now that you've been in there for a bit here now with COVID.
Yeah, sure. Well, we bought the land when my daughter was about 6 months, so I can judge it by that, because she's now 7.5, so that was 7 years ago. And then we got busy with other people's houses, and we took a long time before we were ready to start building. So we started building, I think it was end of 2017, I think. Yes, it would have been. Mid 2017. The contract took a lot longer than we wanted it to, just through a number of things that happened that were out of our control. Nothing to do with it being passive house. So the build actually took, before we moved in, it was 18 months to 2 years. It should have taken a lot less time than that. So we moved in, like I said, it was early 2020 that we moved in.
Gotcha. And now you've had at least a good 1.5 years of experience on the benefits. So we'll come back to that comment. Zach, I think it's time to shoot over to you and tell us what's going on.
All right, great. Thank you. So just a couple of announcements. One is that on the Passive House podcast, we have an interview that I conducted with Sloan Ritchie, who is the owner of the developer and builder Cascade Built here in Seattle. And he's pretty much nearly single-handedly responsible anyway for a wave of multifamily passive house construction that's been happening here in Seattle. So we dive into how he started doing development and how that turned into passive house development, and some advice for folks who might be dreaming about becoming a passive house developer themselves. Tomorrow morning at 10 a.m. Pacific and 1 p.m. Eastern, we have the first Passive House Component Spotlight with us from Proseco. So Prosoco will be presenting air barriers for passive house retrofits and new construction. So they'll go into the building science behind the products and also tips for application on your potential projects. A big thank you also to Prosoco for becoming a champion sponsor recently. So I hope you'll join us. And when I'm done with the announcements, I'll share a couple of links so you can register for tomorrow's event. Next week, we have the Icebox Challenge Sydney kicking off. So on February 21st, that'll get going and it will last from the 21st through March 4th. So I've included the URL iceboxchallenge.org for folks who want to learn more about that. And if you're in Australia and you're close by, maybe you can check it out. It sounds like they're really interesting designs as well. So there's some architecture going on, which is reminiscent of the Vancouver Icebox Challenge that Sian Taylor was a key player in. Speaking of Sian, so Sian is going to be the presenter at next week's edition of Passive House Accelerator Live, which is a construction tech edition. And this is airtightness month here for us at the Accelerator. So he's going to be continuing with that theme with the presentation, How to Not Put a Pin in It, Eliminating Pinholes for Airtightness. So join us next Wednesday, same channel, same time to see Sian and his presentation. Can't wait for that. And then next Thursday, so the day after Sian presents, we'll have episode 5 of the Building Performance Interactive, which is our UK, Ireland-based show. And this one will focus on PH Ribbon. The embodied carbon tool that plugs into PHPP will be joined by PH Ribbon's developer, Tim Martell, for that program. And that's at 2 p.m. GMT, which means 9 a.m. Eastern, 6 a.m. Pacific, and I'm afraid it's pretty terrible hour for you in New Zealand and Australia. But we'll have a recording of it. It should be great. And then the next week, we will be back to a project showcase, the UBC Skeena Student Residence, presented by Jamie Harch of the firm Public. I think that's it for me.